So I just want to thank Aaron and Lucina for inviting me here to give this talk. I think this meeting has been really fantastic, and so my goal over the next 15 minutes or so is just to try not to bring down the mean. And what I want to talk about is uncertainty, because in our everyday lives, we're often faced with the task of interpreting social signals that are not always totally clear. And facial expressions are a really useful tool in our work because they provide a wonderful source of information about the emotional states of another person and also some predictive information about our own environments. For example, if I show you this expression, you could probably easily tell me a story about something negative that this person is experiencing. And if I show you this expression, you could probably also very easily tell me a story, but it's about something positive that this person is experiencing. So while the valence of these two expressions is very different, what's similar about them is that they both have a really pretty clear meaning. Okay, and now compare those to one like this. So I'm sure you could come up with a number of different explanations for this kind of expression. Some of them might be elicited by a really positive experience and some by a really negative experience. So surprised facial expressions have predicted both positive and negative events for us in the past. And one way for us to get at your interpretation of the valence of this face is to just ask you what you think. And so in many of the studies that we run in my lab, people are asked to view these three expressions, and they're asked to rate them as positive or negative. Of course, we're using validated face stimuli in these studies. But again, they're just making a decision every time they see a face, is it positive or negative? So just to orient you, the dependent measure that we typically use is percent negative ratings. So that's simply the percent of times that an item is rated as negative out of the total number of ratings for that condition. And you can see each dot on the graph is a different subject. So all of the subjects are rating the angry faces as pretty consistently negative and the happy faces as positive. But in contrast, we get this really nice range of individual differences in response to the surprised faces. And so what's interesting for us is that when you don't give people enough information, right, to really know if this is a positive or negative expression, there are people that tend to think of this as having a more negative valence, a more negative meaning, and others who tend to think of this as having a more positive meaning. And this tendency for a person to label the face as positive or negative is what we call a person's valence bias. So just a quick example, if you can see the gray dot, the person represented there by the gray dot has a valence bias that's 71%, which just means that on 71% of the surprised face trials, that person thought the face was negative. We've done some work also to test the stability of this valence bias because we think it is some kind of like stable trait-like difference across people. And to do that, we just bring people back to the lab a year later. We ask them to do the same task on a new set of images. And what we see is that there's a really pretty nice stable effect here. People are making the same decisions even a year later. But more recently, we've been thinking about the underlying processes that produce these individual differences. And really, our model is that even though we see all of these individual differences across people, we think what's happening is that everybody kind of starts off more negative, and that the individual differences that we're seeing are dependent on a person's ability to regulate or override that initial negativity in order to see things in a positive light. And we have a bunch of different evidence for this model. I'm not going to go through all of them today, but I'll give you a couple quick pieces of that. One is comes from reaction time data. So you can see here that people take longer to make this valence decision about surprised faces compared to angry and happy faces. But more to the point, they take longer when they're making a positive rating than when they're making a negative rating. Okay, so that suggests that there's kind of an extra step specifically involved in arriving at this more positive interpretation. Okay, so that's one piece of evidence. The next comes from work with kids, which has found that kids, specifically looking at kids ages 6 to 13 years of age, have a more negative valence bias. And this comes from work led by Nim Tottenham. They ran the valence bias task in a group of kids and adolescents. And what you can see here on the right is that the kids ages 6 to 13 have a more negative valence bias than the adolescents. And their adolescents look quite a bit like our adults in many of our samples. Now, this is consistent with our model because kids typically don't have these regulatory mechanisms in place in order to help them to override that initial negativity. And there's evidence for that from a lot of work done by a lot of incredible people. I'm showing just one example. This is work led by Dylan G. And they looked at connectivity between the amygdala and the medial prefrontal cortex in a group of people ages 4 to 22. And what you see is that in the really young kids, there's this positive connectivity pattern between these regions. But what they see is that sometime around the age of 10, there's this shift toward a more inverse connectivity pattern, which is kind of suggestive of like a downregulation of the amygdala. And just to point out that this shift is happening right around the same time that we're seeing that these kids have a more negative bias. So we might predict that the negative bias that's evident in kids, in early kids, in this kind of younger age range, is maybe the normal or even healthy response to uncertainty, but that kids that maintain that negativity bias as they mature may be at greater risk for mood disorders or other kinds of disorders that are characterized by a chronic negativity bias. So in other words, we might predict that kids in later stages of development that maintain that negative bias show increased depressive symptoms. So the first study I want to tell you about today looked at the relationship between valence bias and depression in a population that we know has this more negative valence bias, and also at a time when we know these regulatory mechanisms are likely changing and shifting. So we're really focusing on this age range of 6 to 13. And we're asking, what can we learn from development about the mechanisms underlying the valence bias? So here's the study. We brought kids into the lab. They do the valence bias task, and they also complete a number of surveys, including a measure of puberty. Since we're focusing on this like very constrained age range, we're using puberty as our proxy for maturity within that constrained age range. And we also have them do the revised child anxiety and depression scale, and we're specifically focusing on the subscore for major depression. We have the kids come back about a week later for an MRI session in which they're essentially passively viewing blocks of surprised and neutral faces. So here are the behavioral data, and this is work done with my postdoc, Nate Petro. So you can see, again, percent negative ratings on the y-axis. And the first thing you probably notice is that most of the dots are in the top half of the graph. So essentially, most of these kids do seem to have a more negative bias. So this is just kind of replicating NIM's earlier finding. But what I'm also showing you in this graph is that there's a relationship between valence bias and depression, where it seems that kids with a more negative bias have increased depressive symptoms. And we've done more complicated stats to kind of account for the outliers, and that effect does hold. But remember that we predicted really that in early maturity, there might not be such an effect. And that it's only in later maturity, if those kids are holding on to that negative bias, that they might have more depressive symptoms. And so we looked at this across different pubertal stages, and what you see is that indeed, in early puberty, there isn't a relationship between these things. So maybe the bias, the negative bias, is kind of the healthy response. But that in later puberty, you start to see this effect emerge where a more negative bias is associated with increased depression. Of course, another way to look at this is through a moderation. So you can see that puberty significantly moderated the relationship between valence bias and depression, where only in later pubertal stages you see this significant positive relationship emerge. Okay. But what can the brain tell us about this, right? Because remember, we're looking at all of this in a population when we know these regulatory mechanisms in the brain are likely changing and shifting. Okay, so the first thing I'm showing you here is that in response to surprised faces, we get a region of activity in the dorsal amygdala. But we wanted to look at regions that are functionally connected with this amygdala seed, and that connectivity is related somehow to valence bias and puberty, right? So in other words, this region of the medial prefrontal cortex is functionally connected with the amygdala, and that connectivity has a relationship with valence bias that changes across puberty. Okay, so to try to kind of unpack that, we extracted a measure of connectivity between these two regions for each individual child. And that's what I'm plotting here on the y-axis. And now percent negative ratings is on the x. So what you can see is that across all of the kids, there's not really a relationship between connectivity and valence bias. But what I'm also showing you here is if you look at the colors of the dots, the more cyan, kind of bluish color, those are the kids in later pubertal stages. If you focus just on those dots, what you can see is actually there is a really positive relationship there in later puberty, where those more mature kids that have the positive connectivity pattern, remember that's the immature connectivity pattern, those kids have a more negative valence bias, so these ones, right? But these more mature kids that have now shifted and have this inverse connectivity pattern, so down here, those kids have a more positive valence bias. Another way to look at this, again, is through a moderation. So we see that puberty significantly moderates the relationship between connectivity and valence bias, where developing the more mature connectivity pattern is associated with a more positive valence bias. Okay. So what I've just tried to show you is that early in life, it may be healthy, right, to have this more negative response to uncertainty. But we're proposing that kids that maintain that negative bias and fail to adopt these regulatory mechanisms that help them to see these things in a more positive light, those kids may be at greater risk for depression or maybe other kind of related mental health issues. And we think this line of work is important because if we can learn how people naturally shift away from this fundamental negativity, then perhaps we could use that mechanism to help people that are really suffering from a chronic negativity bias, especially if that negativity is really interfering with their normal, healthy day-to-day functioning. So then, if that's the ultimate goal, right, to try to help people that are suffering from this chronic negativity, then we might need to ask one more question, which is, can we change people, right? So I've shown you some evidence that the valence bias is pretty stable across time, but how malleable is it? So we've done a number of different studies to try to get at this. The first I'll tell you about was trying to promote the more bottom-up signals that we think are pushing people toward the more negative response. And the way we've done that is with a stress induction. So this is work done by Katie Brown, my grad student, in collaboration with Candice Rayo. And what they did is a cold pressor task to induce this state of physiological arousal, and of course predicting that the people that have the greatest cortisol response in this state of stress have more negative ratings of surprise, again, in that state of stress. And that's what we see. So if you look at just the red dots, those are the individuals that underwent the stress induction. These are adults now. And you can see on the right side of the graph for the people that have this greater increase in cortisol in response to that stress, and they're also showing more negative ratings of surprise in that stress state. So this provides some evidence that the valence bias is somewhat malleable, right? And specifically that stress, which promotes this state of hypervigilance, can push people in the more kind of default negative interpretation. Okay, but remember that one of our goals is actually to do the opposite, to pull people away from that chronic negativity. Okay, so the next way we've tried to test this malleability of the valence bias is instead by trying to promote these more top-down mechanisms that we think will push people toward the more positive interpretation. And so here's how we did that. We had, these are again adults coming into the lab. They do the valence bias task in session 1. Then they come back about a week later for session 2, and now they're doing an emotion regulation task. So they're viewing negatively valenced IAPs. These are clearly negative images. And they're asked on some trials to maintain their natural emotional response to those images, and on other trials they're asked to reappraise or to reinterpret the image to be less negative or even positive. And then they're asked to rate on a scale of 1 to 5, how negative did you feel about those images? Okay, so we go through kind of a lot of training with people to make sure they understand how to do this, and then they do this fairly long task, and then at the end they do the valence bias task again on a new set of faces. And so our prediction really is that the ratings of surprised faces in session 2, after doing this reappraisal task, will be more positive than the ratings in session 1. So here are the ratings from session 1. You can see these data look quite a bit like the data I showed you at the beginning of the talk. And here are the ratings from session 2 for the angry and happy faces. So you see there isn't a shift at all in either direction for the angry and happy faces, but we do see this nice shift toward more positive ratings specifically for the surprised faces. Okay. But the next question is, right, I keep talking about this valence bias as if it's like a meaningful, stable, individual difference, right? And so everything I've told you about so far is all related to surprised faces, which is fine, but we want to see how generalizable these things are, right? Is it really just about the responses to surprise, or do other kind of more complex images have the same kind of responses? And so to test that, we've looked back at our faces and tried to find some more complex images that share some of these same properties. For example, this is a great example of an image that might be rated as consistently negative across people, and this one is positive. But this is a really great example of an image that might be rated as negative by some people and as positive by others. And through a number of different studies over the years, what we found is that the responses to these kinds of images look a lot like the responses to the surprised faces, and maybe most importantly, that the same people that tend to rate surprised faces as positive also tend to rate these more complex, ambiguous scenes as positive. And so the last question here is, does the same regulatory mechanism work for shifting the ratings of these more complex images? And so to test that, we ran the same study that I just described, only this time the valence bias task is based on a series of IAPS images, so both before and after the emotion regulation task. And we have the same prediction, right, that reappraisal is going to produce more positive ratings, but specifically for these ambiguous scenes. So here are the ratings from session 1, and you can see, as I've kind of told you, the responses to these scenes look quite a bit like the responses to the faces, right? So there's some similarity here even in session 1. And what we see in session 2 is that there is a shift toward more positive interpretations that's relatively specific to these ambiguous images. And so, of course, this is just another piece of evidence that supports our model, where promoting this more top-down, this more regulatory mechanism seems to push people toward more positive interpretations. And so some of the next steps include a number of different things, really focusing a lot on longitudinal data, which I think will help us to answer a lot of our follow-up questions here, including, how long-lasting are these effects, right? If we know it's malleable, how long-lasting are these effects that we're inducing? Lastly, I was really hoping to be able to direct everybody to Nick Harp's poster, my grad student Nick Harp, who unfortunately already presented his poster, so I'm hoping everybody went just in anticipation that I was going to do this. So thank you for attending his poster. And with that, I want to thank my lab and my collaborators, and of course my funding sources, and thank you for your attention.